Hi students, today we are going to discuss about how to calculate time complexity for merge sort. As we know, merge sort follows divide and conquer approach. So first we need to know how to calculate time complexity for any divide and conquer approach algorithm. Every divide and conquer approach algorithm uses the following recurrence equation to calculate the time complexity. The recurrence equation is T of n equal to a into T of n by b plus f of n if n is not small. Once n becomes small, that is, the problem has become so small which cannot be divided further. In such case, T of n is equal to x. Now let us understand what is A. A is nothing but number of subproblems being generated while we divide. In our merge sort, every time we are dividing the problem into two subproblems. Therefore, A is 2. That is, every time we divide, we are getting two subproblems. Then what is B? B is nothing but the rate at which the input is reduced. For example, if I am having an original array having 10 elements, if you divide, it becomes 5. Means each subproblem gets 5 elements. So B is nothing but rate at which the input is reduced. Then in merge sort, B is also 2. For example, if array is having 16 elements, once if we divide, we are giving 8 elements to each subproblem. So the rate at which the input is reduced is by half, that is B equal to 2. Then what is f of n? F of n is nothing but time taken to combine. Time taken to combine while merging. So we know it well, in merge sort algorithm, we divide the problem into two subproblems. So A equal to 2. For each subproblem, we are giving half of the original array elements. Therefore, B equal to n by 2, that is B equal to 2. And what is f of n is time taken to combine. So how many elements we are going to combine totally? We are going to combine n elements. Therefore, f of n is equal to n. And what is this x? Once a problem has become so small, then we are not doing any activity. It is just taking only one element. So x is equal to 1. Therefore, our equation for merge sort becomes 2 into n by b, 2 into n by 2 plus 2 into n by 2 plus n. So just this is the basic algorithm for merge sort, already we have seen. Let us assume n is power of 2. That is, it is having 4 elements, 8 elements, 16 elements, so on. So time to merge two arrays, each n by 2 is linear, that is n. Therefore, T of 1 equal to 1, that is when n is become small, and T of n is equal to 2 into T of n by 2 plus n. A is 2, B is 2, f of n is n. Now what we do is, we will try to solve the recurrence relation. So we divide the equation 2 by n. Therefore we get T of n by n equal to T of n by 2 by n by 2 plus 1. Similarly, T of n by 2 by n by 2 becomes T of n by 4 by n by 4 plus 1. Again, recursively we are going to divide T of n by 4 by n by 4, which is equal to T of n by 8 by n by 8 plus 1. So on we will be dividing till n becomes 1. That is, it reaches the smallest subproblem. So before the smallest subproblem, how many elements will be there in the array? 2 elements. That is, T of 2 by 2 is equal to T of 1 by 1 plus 1. Now let us add all these equations together from third equation to eighth equation, if you add together, what we get? T of n by n plus T of n by 2 by n by 2 plus T of n by 4 plus T of n by 4 by n by 4 plus so on T of n by 2 by 2, which is equal to T of n by 2 by n by 2, that is 1, T of n by 4 by n by 4, that is also 1, so on T of 2 by 2, 1 plus T of 1 by 1, that is also 1. So if we add all the things, we will be getting the right hand side how much? Log n. That is, when you divide 8 by 2, we get 4, 4 by 2, 2, 2 by 2, 1. So how much time it takes to move from 8 to 1? 3 times. That is, log 8 to the base 2 is 3. So we need to consider this as log n. So therefore, now what we are getting in general, see the ninth equation, T of n by n is equal to T of 1 by 1 plus log n. What is T of 1? 1. So 1 by 1 is what? 1 plus log n. Now let us substitute this in the original equation. So what we are getting here? T of n, cross multiply this, we get n plus n log n. This n has come here, so n into 1, that is n plus n log n. So we know when you do asymptotic notation, approximation, that is nothing but O of log n. Therefore, the time complexity of merge sort algorithm is O of log n. Thank you.